Welcome to the Explainer. So today we're going to take a look inside a device you see pretty much everywhere, the Apple AirPod. What looks so simple and clean on the outside is hiding some absolutely incredible engineering. You know, when you use a CT scan to peer inside, you really see the AirPod for what it is. It's a masterpiece of design, a genuine triumph of miniaturization where every single millimeter of space is used with absolute purpose. Okay, so how in the world did they pull this off? Let's dive in and break down the ingenious solutions Apple's engineers came up with to make a device like this actually work. Here's how we're going to do it. We'll explore 5 key engineering challenges. First, just seeing inside the thing, then powering it, connecting it wirelessly, capturing audio, and finally, controlling the sound you actually hear. So our journey starts with some pretty cool tech, industrial CT scans. Yeah, it's basically like a medical X-ray, but for electronics. It builds a complete 3D model, letting us see exactly how the AirPod Pro 2 is put together without ever cracking it open. All right, let's tackle the first, most fundamental problem every tiny gadget faces. Forget all the advanced features for a second. How do you even get enough power into something that literally fits inside your ear? That's the magic number. Now, 182 milliwatt hours might not sound like a lot, but for a custom lithium-ion battery this small, getting up to 6 hours of use out of it is a huge deal. And it's only possible because of incredibly precise and consistent manufacturing. The secret sauce here is really how the battery is built on the inside. You gotta picture it like a tiny, rolled-up scroll. You've got these essential layers, the cathode, the anode, and the electrolyte, and they're all wrapped up as tightly as possible to squeeze every last drop of energy capacity into that tiny space. And this is where that manufacturing precision really matters. When you scan a knockoff, the difference is just, well, it's stark. You can see gaps and really sloppy layering. That poor packing means less battery life for sure, but it also means more energy is wasted as heat, and the battery just wears out way faster. But here's the catch. That super tight packing is also its Achilles heel. Dropping your AirPods or even just walking from a warm room out into the cold can stress these internal layers. That stress can cause the electrolyte to break down, creating permanent dead zones where the battery just can't hold a charge anymore. Okay, so you've got power. Check. What's next? The connection. I mean, we live in a world that is just flooded with wireless signals, Wi-Fi, microwaves, other Bluetooth devices. So how does a tiny AirPod maintain a perfectly stable connection through all that noise? The answer is this really clever trick called frequency hopping. Instead of just picking one lane on the highway and hoping for no traffic, it's like your AirPods are constantly jumping to the open lanes, switching between dozens of different channels every single second to find a clear path before any interference can even cause a problem. But for that to work, you need a great antenna. And this is where it gets kind of wild. Your own head is actually really good at absorbing and blocking these 2.4 gigahertz signals. So Apple had to be clever and place the antenna down in the stem, pushing it away from your head just to get a clear line of sight. So how do you fit a complex antenna in that tiny stem? A flat one on a circuit board just isn't going to cut it. Apple's solution is brilliant. They embed a 3-dimensional antenna directly onto a plastic support. A laser carves the exact path into this special plastic, and then that path gets plated with copper and gold. The result is a perfectly shaped 3D antenna that would be basically impossible to make any other way. Okay, so we have power and we have a solid connection. The next piece of this whole puzzle is sound itself. How do you capture crystal clear audio for phone calls and commands with parts that are so small you can barely even see them? While a lot of the knockoffs use these older, less reliable things called electret mics, AirPods use something way more advanced: MEMS microphones. MEMS stands for Micro Electromechanical Systems, and they are literally manufactured with the same mind-blowing precision as computer chips. And the scale we're talking about here is just staggering. The entire microphone component comes packed in this tiny metal box, just 3 millimeters across. But that's just the protective shell. The actual recording element, that tiny flexible plate that vibrates with sound, is microscopic. It's built layer by layer on a silicon wafer using a process called photolithography. They're essentially printing a mechanical device the same way you'd print a circuit on a computer chip. It's wild. All right, for our last section, let's see how all this incredible tech comes together to actually control your soundscape. managing everything from phone calls to noise cancellation to deliver that signature sound. Having multiple tiny mics lets them do some really smart stuff. For your phone calls, they use a trick called beamforming. The system uses two mics to detect the tiny 6-microsecond delay as your voice hits each one. That tiny difference is enough for the chip to pinpoint where you are and filter out all the background noise. And for Hey Siri, it's even cleverer. A low-power accelerometer feels the vibrations in your jawbone, waking the mics only when you start to speak, which saves a ton of battery. And when it comes to active noise cancellation, AirPods use this really sophisticated two-pronged attack. A feed-forward system uses an external mic to listen to the world around you and create an opposing sound wave to cancel it out. But it also uses a feedback system. An internal mic measures what you're actually hearing inside your ear, and it constantly corrects the signal in real time. The result is a much, much cleaner sound. So what about the actual sound quality itself? You know those little black meshes on the outside? They're not just for looks. They are precisely engineered acoustic vents. Their job is to control airflow and pressure inside your ear, which stops weird sound waves from building up and resonating. It tunes the audio to sound natural and perfectly balanced. But wait, if you have holes in your device, what about water and dust? Well, they thought of that too. These vents are protected by a hydrophobic nanocoating, which is a technology they actually adapted from the iPhone. It repels moisture and junk while letting air and sound pass right through, completely untouched. So when you take a step back and look at the whole picture, it's just incredible. Every single part we've looked at, the densely packed battery, the 3D laser-etched antenna, the silicon microphones, the complex web of sensors, every one of them is an ingenious solution to a huge engineering problem, all working together in a space smaller than your fingertip. It's a stunning testament to what's possible in modern electronics, a true marvel of engineering. And it really makes you wonder, if this is what we can do today, what comes next?